Okay. Yep. Sorry about the delay. Let's start with the lecture. Today, I will discuss with you as an extension to the verification and validation activity in the software process, the software testing. As you know, software testing is the so-called dynamic verification technique. Um, uh, is there any problem on the screen? Can you see the entirety of the screen, or are there any problems? Can you give me an answer through the chat, please? Okay. Okay, great. Thank you. Um, well, I am sorry. Sometimes I'm just stopping for a few seconds to admit the newcomers. Okay. Well, let's start with the software quality concept. At let's define, according to the standard glossary of the software engineering terminology from the IEEE, what the quality concept in general means. It is defined in two points. The first one is the degree to which a system, component, or process meets specified requirements. So we can also think in a general sense that the software process is included within that definition, because it should meet some specified requirements. And the second point of the general definition of the quality concept is that the degree to which a system, component, or process meets customer or user needs or expectations. So you are also familiar with that from about the start of the class, that validation is actually to ensure that the software product meets the user's needs. So here the quality in general terms is defined again using these 2 points. Okay, let's now look at the software quality in particular. What is it? It is the conformance that it conforms to. It corresponds to the explicitly stated functional and non-functional requirements. Well, an example is performance or maintainability or availability, etc. It also should conform to explicitly documented development standards. So there's a standard enforcement here, you see. And also to the implicit characteristics that are expected of all professionally developed software. So this has 3 remarks here, let's say three points. The first one is that it conforms to explicitly stated functional and non-functional requirements. It conforms to explicitly documented development standards, and it conforms to the implicit characteristics that are expected of all professionally developed software. So now let's come to the dimensions of the software quality. This is an important slide here. It defines 3 dimensions of the software quality concept. The dimensions are adaptability to new environments, the ability to undergo change, and the operational characteristics of the software. Well, these dimensions are um, uh, provided, are maintained, are contributed to the software product by the given system properties, by the corresponding system properties. For example, the quality of the software product from the viewpoint of the adaptability to new environments is assessed by its portability, reusability, and interoperability. So these three system properties are directly related to the adaptability to new environments. Maintainability, testability, and flexibility are the three system properties that directly define ability of the software product to undergo change. So in other words, from the assessment of the maintainability, testability, and flexibility of the software product, we can deduce, we can extract how capable the software product is of undergoing changes. The system properties, correctness, efficiency, reliability, integrity, and usability, on the other hand, define the operational capabilities of the software product. From measuring correctness, efficiency, reliability, integrity, and usability of the software product, we can say how how its operational characteristics are built. Okay. Do you have any questions so far? I will start in the coming slides the definitions of. I will actually review some of them, some of the definitions of some of the system properties that you already know, and some of them you will hear brand new. Do you have any questions so far before going any further? Please write your questions if you have any from your chat panel. Okay, so let's continue then. The portability. Okay, we will first look at these three system properties for adaptability in the dimension of adaptability to new environments. Portability is, as you know, the effort required to transfer the system from one hardware and or software environment to another. So portability is another term for, or very similar to platform independence. It is the effort required to transfer the system from one hardware or software environment to another. So, as you know, we have learned how to assess the proper portability of a software product in the specification of software, in the chapter of specification. Okay. Well, this is a new system property to you. This may be a new system property to you, reusability. It is the extent to which the system or part of it can be reused in other applications. Okay, so this is, okay, you of course know the concept from the former discussions in this class, but we define it. I don't remember defining it previously, so we define it here for the first time. It is the extent to which the system or a part of it can be reused in other applications. So this is also a system property that goes along with the adaptability to new environments. Interoperability is another system property that is associated with the adaptability to new environments. This is the effort required to couple the system to another. So we check out to see the interoperability of a software product to see how capable it is to be connected to another another software system. Okay. Well, here maintainability is a system property that you have learned before. We have discussed its definition before. It is the effort required to introduce a modification into the system, and this modification is usually a correction of the system. Sometimes, whenever it is not, it is a change that is demanded by the customer to be made to the system. Okay, this is a system property related to the ability to undergo change of the software product. Flexibility, another one that is related to the ability to undergo changes. It is the effort required to modify or customize the system in operation. Okay, so and testability is another system property that also is associated with the adaptability to go under change for the software product. It is the effort required to test the system to ensure that it performs its intended function. For example, the testability gives us the ability, the capability of the system, how easy it is, to what extent it is easy to test the system for a given function of it. Okay. Well, here, for example, okay, let's see. In all of these, maintainability, flexibility, testability, I'm given this discussion as an example to the dimensions of the software quality. I take this second dimension, which is the adaptability to go under change. You see here these three: maintainability, flexibility, testability. These are all system properties related to the adaptability of the software product to go under change, and each of these imply that the system should be as modular and as possible, and each module should be as independent as possible. So these three system properties impose that the software should exploit the property of encapsulation. Okay, the objects, the classes, the modules should be as encapsulated as possible. Okay, so that definitely contributes to the adaptability of the system to undergo changes. Okay, this is an example. You may look from your book, and you may also look from other resources, that these three system properties define the features of the software product, how to be easily changeable. Okay. Now let's look at the Let's look at the system properties for the third dimension, which is the operational characteristics of the software product. Um, these are the correctness, reliability, efficiency, integrity, and usability. Now let's see what the definition for the correctness is. It is the extent to which the system satisfies its specification and fulfills the user's needs. On the other hand, reliability is the extent to which the system can be expected to perform its intended function with required precision and without failure. So, for example, correctness and reliability. These are features of the software product with very close definitions. But you can look at it this way. You can think that if a system satisfies its specification and fulfills user needs, then it is correct and it is also reliable, because the system, we have defined the reliability as the feature in the critical systems specifically, that this is the property of the software product uh, as the extent, as the probability with which it conforms to its specification. So correctness and reliability this way are very similar concepts, very similar features of software product. Efficiency is another characteristic of the software product. It is the amount of computing resources like space, time, required by the system to perform its function. So here, the less space and the less space software product uses, and in and it fulfills its function in as small as possible amount, then it is more efficient. So I'm sorry, it has been a bad definition. Let's try it again. The less space a software product uses, and it takes for a software product shorter the system to perform its function, the more efficient we can say is a software product. Okay, that I think that's better. Okay, integrity, another system property, is defined as the extent to which access to the system or its data by unauthorized persons can be controlled. Okay, integrity is also a part that is included by the security. Integrity is related to the security of the software product. Okay, usability, we also say that, we also call it user friendliness, is the effort required to learn, operate, prepare input, and interpret output of the system. So usability is another system property associated with the operational characteristics. Now, do you have any questions so far? Do you have any questions so far? You can raise hands, or you can write from the panel if you have any. Okay, don't hesitate if you have any questions. Please write from the chat panel. Well, let's continue with the software quality again. This time, software quality, quality assurance is defined in the IEEE standards. It has again 2 points. It is defined in 2 portions. The first portion says that it is a planned and systematic pattern of all actions necessary to provide adequate confidence that an item or product conforms to established technical requirements. So, quality assurance defines or describes a group of actions, a set of actions. Okay. And this set of actions is planned and bears a systematic pattern. Okay. And what does it do? What does it give us? What does it provide? It provides adequate confidence for the customer that the item, the software product, conforms to established technical requirements, that it conforms to the requirements determined or set in the specification. Okay, this is the first point of the quality assurance. The second point is a set of activities designed to evaluate the process by which products are developed or manufactured. Okay, here, at the second point of quality assurance, it describes another set of actions where the process, the development and manufacturing process of the software product is evaluated. Okay, so these are the 2 portions. These are the 2 points that together describe the quality assurance in software engineering. Okay. Well, let's look at the quality assurance a little in detail. It is composed of several factors here. Or several activities here. It is an application of sound technical methods and tools. So to assure the quality of software, we have to apply sound technical methods and tools in its development and in the entirety of the software process. As a matter of fact, we have to apply sound technical methods and tools. At the second bullet, we learn that while verifying it, we have to use formal technical reviews and inspections. Okay. So the second point, in the first point, we learn that sound technical methods and tools should be applied in the software process, in any activity of the software process. In the verification, in the second bullet, we learned that in the verification, we have to use formal technical reviews and inspections. That is static verification methods. At the third bullet, we learn that we have to apply software testing definitely as a dynamic verification method. At the fourth point, to assure quality, we have to enforce standards. Standards from at the different activities of the software process, we have to enforce standards. From specification of the software, we have standards. From the viewpoint of specification of software, we have standards. And also at the development and also at the verification, we always have standards to conform to, and we have to enforce these standards during the software process. Documentation is another important point that assures quality. Well, the documentation, as you know, is crucial for of the process. The documentation of the process is crucial for the visibility of the process, so that the managers can track can follow how well the development process is going, the specification has been done, etc. Further, the documentation of the product is also important to guide the product, to see how it works and what details, what technical details it has, etc. So the documentation is another inevitable point of the quality assurance. Control of change. Okay, this is another important thing of quality assurance. How should we change the product whenever necessary? How should we debug it? How should we perform debugging sessions once we have tested the product? So, in other words, or in another way expressed, is the product maintainable? The answer to this question is the control of the change to the software product. So this is another important point that that complements the quality assurance. Okay, extensive software testing is another important point of the quality assurance. Finally, record keeping of reporting of the process. We will see that in a bit in the or tomorrow possibly in the coming slides, that for example record keeping and reporting of the testing is extremely important to debug it, to see in what to see for the future engineers what problems it has survived, experienced the software product, etc. So these are the important factors, important points of the quality assurance. Okay. This year, you know this from our introductory discussions that verification means, are we building the product right, and validation means, are we building the right product? These are questions that use the same words, but they have very different meanings. Okay, now in this slide we add to what you know another dimension. Okay, validation is the activity in the software process that extracts specification document from the user needs. Okay, validation or the answer to the question, are we building the right product, serves to the obtainment of the correct specification document from the user needs. Okay? And verification, or the answer to the question, are we building the product right, serves to the extraction of the correct software product from the specification document. Okay, so this is the these two concepts, validation and verification, couple or connect user needs to specification and specification to the software product in respective order. Any questions so far? Anything you wanna ask? Anything that you don't understand? Please raise your hands. Please communicate with me through the chat panel. If you need, I can also unmute you. Don't hesitate to ask questions, guys, please. Okay. Now let's look at the principles of software testing. Well, we have several principles for software testing. Let's look at them. First, what is testing? It is a process of executing a program with the intent of finding a defect. So, we wanna extract defects. We wanna find out defects, and this is our intention when we test a software product. Okay. Doğuşan, can you hear me? What is a good test case? It is one. Oops. Doğuşan, can you hear me? Doğuşan, can you hear me? Okay. Why do you have two requests you have two different requests? Why is that? Well, a good test case is one that has a high probability of finding an as yet undiscovered defect. So the test cases, the program input that is, should be selected systematically and with care, both for correct and incorrect behavior. So you will see in our example, in the coming slides, that we should test the system for its correct and incorrect behavior. Okay, so this is important. A good test case, that is, test inputs, should be one that has a high probability of finding an as yet undiscovered defect. Okay. Oops, sorry. A successful test, what is it? It is one that uncovers an as yet undiscovered defect. So we want to uncover a defect that has been not discovered yet. So this is a successful test. Okay. So looking from that viewpoint, from the third principle, testing is, I mentioned that before, testing is psychologically destructive. Why? Because a successful test is one that shows us a problem in our software product. Okay, so from that viewpoint considered, testing is destructive, psychologically destructive, since it tries to demolish the software that has been constructed. Okay, so this is an important point to know. Okay, well, the principles of software testing continue. The fourth one here says that testing cannot show the absence of defects. It can only show that they're present. Okay, so this is Dijkstra's word. Well, this also tells us this tells us that if a software product has passed all tests that we applied, that doesn't mean that it is free of bugs. Okay, it still may have bugs that we failed to uncover. Okay, so let's look at the fifth principle of testing. Testing is quite ineffective method of quality assurance, though usually the most applicable one. So uh, we will talk about it. Uh, it takes a lot of time per defect to uncover it. So that's why in reality it is an ineffective method. But this is the only there are other methods like static verification, inspection, etc. But this is the most applicable method. Testing is the most applicable method. Well, of course, inspection combined with testing or static verification methods combined with the testing are the best, of course, we have. Sixth principle of software testing is successful testing shall be followed by a separate debugging phase. So successful testing means that we have found out a problem, a bug in the software product. So now what we need to do is to debug it, to find out where it is exactly, and then uh, we have to correct it. We have to remove the problem. And the seventh principle of testing is that testing is also by itself a process that must be systematically managed and assisted with special testing tools, because systematic testing is extremely important. You don't want to test a portion of software product, for example, that you have already tested, or you don't want to miss a portion of the software product to test if you didn't intend it. Okay. Well, let's look at the jargon of testing. Well, okay. We're almost at the end of the lecture, so let's. If you have any questions, let's ask them. Otherwise, I will see you tomorrow at 8:30. Do you have any questions? Any questions? Okay, then. I will stop here and I will see you at 8:30 tomorrow. Bye-bye.